Hi, everybody. Welcome to topic number 14. In this video, I'm going to talk about multiplication rule for probability. So in topic 13, we talk about addition rule for probability, where we see event A or event B occurring. So the word or in probability means, you think about addition. Okay. So the word and in probability, you actually multiply if you got two events. So let's take a look. Two events, E and F, are independent. Okay, so multiplication rule, you got to think about something called independent or dependent events. If two events, E and F, are independent from each other, if the probability of E, the first event, so E is always the first event, does not affect the probability of the second event. Okay, so if the two events are independent, then probability of the first event does not affect probability of the second event. So a long time ago in previous topic, we mentioned the wording called with replacement and without replacement. Okay, so that concept actually comes in with the dependent and independent, okay, event. So we say two events are dependent if the probability of the first event does affect the probability of the second event. All right. So this multiplication rule is for two independent events. So if you got two events that are independent from each other, then probability of E and F occurring, probability of the first event and second event, okay, will equal to the probability of the first event times the probability of the second event. So for example, suppose you draw a card from a standard deck, and then draw another card without replacements. Okay, so I'm drawing two cards. So the events are drawing an ace and drawing another ace. So those are the two events. My events are drawing ace and drawing another ace. So without replacement, that means if I draw an ace on the first event, on the first, for the first card, and once I draw it out and I do not put it back into the deck, so that means a second event, which is drawing another ace, is going to be affected by the first event, right? So these two events are dependent to each other. So let's think about this. By the rule, by what, with the word and, we will multiply. Because the two events are dependent, okay? So then what's going to affecting is a second event. So the first event, probability of drawing an ace, okay? There are 4 ways to draw an ace out of 52 possible outcomes. But the second one, without replacement, means if I do draw an ace, right, I don't put that card back. So if I don't put that card back, that means there should be only 3 ways I can draw another ace out of. Well, if I did not put that first ace back, then that means there's only 51 possible outcomes, right? In other words, you can say there are only 51 cards left in the deck. So this is what I mean by without replacement, or the two events are dependent to each other. So 4 times 3 is 12 out of 52 times 51 is 26, 52. Right, so that will be your answer. So that's the probability of drawing an ace and then draw another ace without replacement. So with replacement, same thing, drawing an ace and drawing another ace. Okay, so once again, the word and means we will multiply the two events. So this time, probability of drawing the first ace still going to be 4 ways out of 52. Now, once I draw that card out, once I draw that ace, I put it back in the deck. So my second event drawing another ace, I should still have 4 ways out of 52 because I put the card back. So that's why these two events are independent to each other. So 4 times 4 is 16, 52 times 52 is 2704. All right, so just kind of quick 2 example explaining dependent and independent events. Here's another concept I want to introduce called the conditional probability. So if the second event does getting affected by the first event, okay, then those are what we so called the conditional probability, because the second event is based on the condition of the first event, what happened with the first event. So conditional probability will occur if the probability of one event affects the probability of another event, okay? So the problem I just did, the without replacement is considered as a conditional probability. All right, the notation, okay, probability of F slash E. This thing reads probability of the event F occurring on the condition, the slash means on the condition that the event E has already occurred. So if I say a different way, this notation is really saying find the probability of the second event, right? F is the second event, E is the first event. Find the probability of the second event given that first event has already, given that the slash, given that the first event E has already occurred. All right. So here is a multiplication rule for dependent events. It's really probability of the first event and second event occurring is going to equal to probability of the first event times probability of the second event, given that the first event has already occurred. Just like this 3 out of 51, right? Because this second ace is this drawing another second ace is the second event, given that the first event has already occurred. So without replacement, that means you only have 3 ways to draw the second ace out of 51 cards in the deck. All right, so let's try this example with the tables. Okay, we're gonna read this a little bit carefully. So let's say Mr. Chan's math class has 106 students classified by academic year and gender. So we got freshman, sophomore, junior, senior, male and female. 106 students. What is a probability that he selects a female, okay, given that he chooses randomly from only the sophomore? So the problem want me to find the probability of selecting a female, given that he chooses only from sophomore. So this is a little bit strange. Because if you think about in terms of my notation up here about E and F, all right, if I'm writing as a conditional probability, then the first thing I wrote is the second event. F is the second event, because I'm trying to find the probability of finding a female given that first event already occurred, that E already occurred, first event has already occurred. So the first event, okay, the first event is referring to sophomores. So this is where it's a little bit tricky to think about. Sophomores. Sophomores are right here. So that means there are 23 sophomores. What's my probability of selecting a female? Well, female is only 5 of them. So my answer will be 5 ways to select a female. Okay, out of my total possible outcome of sophomore, which is 23. Okay, I want you to think about that a little bit. The first event is selecting sophomore. So if I look at the sophomore, there are 23 of them. But I want to find the probability of selecting a female. So female is 5 of them out of 23 sophomores. Okay. Now, vice versa. What's the probability that he selects a sophomore given that he chooses a female? Okay, so that's a little bit backwards. So this time I want to find the probability of selecting sophomore given that female already occurred, given that there's female. So female is not the first event. Sophomore is the second event. All right, female is the first event. Okay, so what's my probability of selecting a sophomore, given that there are females? Sophomore is only what? 5 again. So this time it will be 5 sophomore, excuse me, five sophomore, given that is female. So how many female do I have up and down here? If you add them all up, there should be 50 ways to select, 50 possible outcomes for the female. So I'm only selecting a student, right? A female or a sophomore. So, so that's why if you add them up, I have 50 ways to select that one, that one female. All right, let's try another one, okay? Number 3, what's the probability that a sophomore female and then a senior male are chosen? So that's 2 different events here. So this is a probability of sophomore female. And selecting selecting a senior male. Right, so by the rule, it's basically, I'm not gonna write all out in words. So this is gonna be the probability of sophomore female times senior male, given that sophomore female, right? Sophomore female is the first event. This is the second event. So sophomore female. Remember, there are 106 students in the class, right? Sophomore female. Sophomore female is 5. There are 5 ways to selecting your first event. There should be 5 ways to selecting a sophomore female out of 106 possible outcome, and tell me to multiply. So the second event depends on what the first event is. Okay, so this is a conditional probability. Senior male. Seniors right here, male 17. Okay, so by look at it, senior male and sophomore female are independent from each other. So there are 17 ways to selecting that senior male. But this is still a conditional probability, because once I select that one sophomore female first, that student is out of that 106. So when I selecting the senior male as a second event, there's not 106 students left. There should be 105 students left. That's the reason why this is still considered as a conditional probability. Okay, the sophomore female, senior male are the independent from each other. But when I selecting the second event, it still depends on what? It still does depend on what happens, okay, with the first event. So that's why it's still part of the probability. All right. So here, real quick in the calculator, it's gonna be a real big number. 106 times 105. Give me this big old number, 11130. 5 times 17. That's 85. So there are 85 ways out of 11,130 possible outcomes. Okay, so if you divide this in the calculator, then you will see what the percentage is, which is real small. Okay, let's try a different type of questions away from the table. All right, this one says a box contains 5 green marbles and 13 white marbles. Okay, so I got green and white. If the first marble chosen was a white marble, so that's the first event already occurred, what's the probability of choosing without replacement another white marble? So this question is actually, it's not saying choosing a white marble and another white marble. This question is only asking me the second part which is the second event part. This question is only asking me, what's the probability of selecting a white marble? Given that a white marble already selected. I hope that makes sense. It's not, the question is not like this one here, the sophomore female and then a senior male. Okay, it's not asking the probability of that. It's only asking the probability of selecting the second white marble, given that the first one is already a white marble. So let's think about this. Okay, second event. If the first event already occurred, is the white marble, then when it comes to finding the probability of the second event, there should be only 12 white marbles left in the box. So there are 12 ways, right? Because I'm only selecting one out of what's my denominator should be. Well, the box contains 18 marbles together, right? 5 plus 13 is 18. But without replacement means once I select that first white marble, I'm not putting it back. So when it comes to the second time I'm selecting a white marble, there should be 17 marble left in the box. Okay, so that's 12 out of 17. That's a probability. All right, 2 cards are drawn without replacement from a standard deck of 52 playing cards. What's the probability of choosing a jack and then a queen? Okay, so your first event is finding a jack. Second event is selecting a queen. So this question is asking probability of getting a jack and a queen. So I'm drawing 2 cards, basically. 2 cards are drawn. So by our definition, this is finding the probability of jack. So this problem is, it's not that many words. I'm going to write it out for you, okay? Probability of finding a jack times probability of finding a queen, given that I already select a jack without replacement. So your first event, jacks, right? There are 4 ways to select a jack out of 52 possible outcomes times. There are how many ways to select a queen? Because selecting jack, selecting queen is kind of independent from each other. So so that means I should have 4 ways to select a queen. Given that the first card is already jack and without replacement means there should be only 51 cards left in the deck. So by the time I'm selecting the queen, there's only 4 ways to selecting those 4 queens because I'm only drawing 1 card here in the second event out of 51 total possible outcome because there's only 51 cards left in the deck. So this is going to be 16 over 52 times 51. I think 52 times 51 is 2652. All right, so that's my probability. All right, let's try another one. So this one here is very interesting. I'm gonna draw a table for you. So other examples I did where the tables were already given, but this one I'm gonna draw a table for you. Out of 300 applications for a job. Okay, so total people is 300. 145 are male, 51 are female, and have a graduate degree. So the 51 are male and have a graduate degree. So 51 people have graduate degree. So this is how I'm gonna draw. Okay, so I basically have graduate degree, and no graduate degree. So if you read through this problem, it's kind of confusing. That's why drawing a table helps. And I know right now there are male and female. Okay. So I'm gonna draw a line, kind of divide the graduate degree no graduate degree. Okay, I'm gonna draw this line a little bit longer. So there's a little space down here below it. Make a little extra space. You will see where it goes. Okay. So first thing first, we know there are 51 male and have a graduate degree. So graduate degree male 51 goes here. Okay. 145 are male. So that's a total number of male. 145. So where does 300 go? The 300 is a total number of applicants. So that 300 should go right here in this very bottom right corner. So these little extra space here is where the sum is. If you sum up across, it goes right here. If you sum up vertically, it goes in the bottom right here. Okay. If 94 of the applicant have graduate degree, so that means it did not say the 94 are male or female. It just said 94 have graduate degree. So that 94 got to be right here. Because this horizontal, this row is graduate degree. We disregard male, female. So male, female together is 94. Okay, that's so this spot is where 94 goes. If 94 applicants have graduate degree, what is the probability that a randomly selected applicant is male? So this question is want me to select male, given that the applicant has a graduate degree. So this is similar to the one we did earlier. So graduate degree is the first event. The second event is about find the probability of a male. So your first event is about graduate degree, right? Graduate degree, there are 94 applicant total. Very similar to this very first one we did. Sophomore, 23 of them, okay? Probability of having graduate degree, okay, find the probability of a male given that has a graduate degree. Male given that has a graduate degree. So that's 51 out of 54. There you go, right? Male, find probability of male given that it has a graduate degree. Graduate degree is 94. And there are 51 male that have a graduate degree out of 94. So that's your answer. Okay, so just kind of real quick, if you few example explaining what multiplication, how we can use multiplication rules for probability, and what and kind of mentioning what is independent and dependent events. Okay, and how we use the concept of dependent independent events in this conditional probability. All right, thank you for watching.